All right, so we're going to graph these linear inequalities, and it just requires that you remember your skills about graphing an equation. If you can graph an equation, you're going to be just fine. You're going to need a highlighter, so take one out, and if you didn't bring one with you, I've got a basket of them right there if you promise not to take it with you. You can borrow one of my highlighters if you'd like to, but you're going to need it today. I'm also going to give you a sheet of Miss Olson graph paper. I forgot to run it off, so some of you are getting one that has 6 graphs instead of 4 graphs. A little bit smaller, but it'll be okay. It'll work the same. And they didn't have these don't have holes punched in them. I'm sorry. Just make sure you return those highlighters when you leave. All right. Will you trade with me? One of you that has the 4. All right. So let's talk about graphing a linear inequality. First off, do you remember how to graph a linear equation? Write with me. Example 1, y equals negative 5x plus 3. You know where the slope is and where the y-intercept is because we've been writing equations this week, right? You know about the m and the b. So go to your graph paper. Do this for me to be neat and organized. Put today's date. And then go over to the first one, whichever one you're going to use first, and put an example 1 there so that your notes will match your paper. All right? Let's graph y equals negative 5x plus 3. Where do I start, Trey? In the center. And where do I go? Where do I go first? Up 3 on the y-axis. There's my y-intercept, right? Pretty good with that? From there, what am I going to do next? I'll stay at that spot, and what do I do next, Benjamin? Because my slope is negative 5 or negative 5 over 1. If you need to write that down, that the slope is negative 5 over 1, now I'm going to go down 1, 2, 3, 4, 5, then which way? Positive 1. That's right. Negative 5, and I go all the way to the edge, positive 1. All the way to the edge. Down one more time. 1, 2, 3, off the graph, 4, 5 over 1. Now, when I go back up to here, how do I handle doing the rest of the graph? I'm going to go up positive 5, 1, 2, 3, 4, 5, and then what? Negative 1. So I can just reverse it and go positive 5, negative 1. All right, everybody with me? And then what do we do with those dots? We connect them with a straight line. Draw them straight through. Okay, good review? That's our first equation. Now, let's talk inequalities. Back on your regular paper, I need you to write with me. Let's graph 3x plus 1/2 y is less than 2. Is this graphable? Is it ready to graph as it is? No, we need to rearrange and isolate y. Can you do that now? First, we'll get rid of the 3x. I remember teaching you this, and now you know it so well. And we're left with 1/2 y. Was that an occasion to flip the sign when I just subtracted 3x? No. And I'm going to put that minus 3x in front of the positive 2, aren't I? So it's in slope-intercept form. Then what do I do about this 1/2? Yes, times the reciprocal, or in other words, times 2 will get rid of it, won't it? Multiply the left side times 2 and multiply the right side times 2, the whole side. Was that an occasion to flip a sign? So now we get y is less than negative 6x plus 4 because it was the whole side, right? Okay, great. We've got it ready to graph. Can I ask you to not work ahead of me on the graph? Will you just work with me for a second? Because there's something you've probably forgotten. All right, so let's just go to number 2, and I want you to graph the points, but don't connect them. Graph all the points. So start with your y-intercept, graph it. Then your slope, and graph some points. And go back to the starting point and go up. 1, 2, 3, 4, 5, 6, 1. But don't connect them. We got to talk about when you do and when you don't. Look at number 1 again. That right there says that y equals negative 5x plus 3, doesn't it? That line says it equals that. If we draw a line right here, we are saying it equals negative 6x plus 4. Does this say equals? No. Could it say equals? Yes. Could it have a line under it and say equals and we would draw a line? Yes, but it doesn't. So instead we do what? We do a dashed line because this does not equal it. It just starts there. That is what's known as our boundary. So we make this a dashed line, not a solid line, to show this is where the solutions begin, but that line itself is not a part of the solutions. Yes, Terralyn? Yes, that's why I gave you a highlighter. Instead, the solutions begin here, but the solutions are actually all numbers less than that line. Where are the numbers less than that line? Where would you say, guys?
Left side.
Yes, look right here at the line. It says y is less than. Do you see where the y-axis is below the line right here? You see that? This is the part we need to shade, the part that is below the line. It's sometimes a little bit hard to see when the line is almost straight up and down, but this is the part that's below the line. Quickly go and shade it all in. Quickly, but without wasting time. Like, don't be OCD about it. Just get it shaded. All right, did that come back to you pretty well? Remember how that's supposed to work? All right, let's try another one. I'll give you another second to shade. No, I'm not interested in looking at your mess. Make it look nice. The ones I give you in a minute will be smaller, so you won't have quite so much shading. All right, example 3. Can you go back to your notes with me? Let's see if you can do this one without me. X minus 2y is less than 4. First, get it in its graphable form. Will subtracting x make us flip the sign? No. Will dividing by 2 make us flip the sign? Yes. Now I have a question. How do you handle this? A negative divided by negative is a positive, but how do you handle x divided by 2? Yeah, it's like a 1x, isn't it? So that becomes 1/2 x. We don't want to leave x over 2. We need a slope in front of x. So we make it 1 divided by 2, 1/2 x. You with me? Do we also have to divide the plus 4 by 2, by negative 2? Yes, we do. Now that you've got it, go graph it. Label example 3 and go graph it. Solid line or dash line? It's another dash line. Figure out where to shade. And that's the part that's above the line, isn't it? Isn't that the part above the line? So that's where we're going to shade. Oh, you scared me, because I very well could make that mistake. All right, take one of these. Okay. Negative, wait a minute. The slope is... I did do mine wrong. Mine's wrong.
Yeah, yours is.
Mine's totally wrong. What's wrong with mine? What's backwards? I did a negative slope. It should have started at -2 and gone up 1 over 2, up 1 over 2. That is what cold medicine will do to you. And we still shade above, so we shade right up here. I'm so sorry. I'm sorry, guys. Does that make sense? You didn't copy mine, did you?
Everyone makes mistakes.
Yes, everyone makes mistakes. You didn't start. Yes.
Solve it again.
Yeah, that's what you want to see?
You know what I'm saying?
You want to talk through it again? Okay. So I'm trying to get y by itself. So first I'm going to get rid of x by subtracting x from both sides, right there. Yeah, I got to subtract x. So the negative 2y is still there, less than negative x plus 4. Then I'm going to get rid of that negative 2y, this means negative 2 right there, by dividing by negative 2. Okay, guys, take one of these. Can I give you one? I hadn't told you which one to work with. Hold on. Okay. Would you put a Naya's name on for me and put it in that water basket over there? Here you go. All right, everybody look at number 1 because I kind of want us to do this one together. First one together. Look at that equation. Is that an equation? Number 1?
Yes, it is.
Okay, so let me ask you about it. It's going to be is it going to be a dashed line or a solid line?
Yeah.
It's going to be a dashed line, and I've got a 1 right here. Now think, join me on this. Is that 1 the y-intercept or the slope? How do you know?
Because there's no x.
Because there's no x with it. So that's the y-intercept. That means we start by putting a point right there at 1, don't we? That's where it's going to cross the x-axis. Are you following? Now, what's the slope?
0.
Something made x completely disappear, didn't it? What coefficient would make x completely disappear?
0.
0. This has a slope of 0. Look around the room. What does the 0 slope look like? It's a straight horizontal line. That's an undefined slope. Look at 0 slope. Straight across. Dashed or solid? Dashed. Straight across. And when it comes to y is greater than, where are we going to shade? Above it. I don't have a shading option on the board here, so I'm just doing it like this. You with me? Okay. I wanted to do that together. Right now, I'd like you to do very quickly, this is not the last thing we're doing today, numbers 3, 5, and 7. You got it? Circle them right now. 3, 5, and 7. Go. Can you do it in 10 minutes? That would be ideal. Or less. Mm-hmm.